In this lecture, we are going to see how we can catch some of the standard built-in exceptions from C++. And we are going to be using our animal hierarchy. So the base class is going to be animal. We are going to derive from this and create a feline class. And this is going to be using polymorphism. So we're going to set up an inheritance hierarchy like this. Here is a simple example of something we might do that may throw an exception. For example, we have an animal object created, and down here we want to cast this animal to a feline reference. From what we already know, this is already going to fail because the animal object we have here doesn't have any feline information inside. So if we try to cast this to a feline reference, this is going to fail. But because we are casting to a reference, this has no way to give us a null pointer that we can do a check on. So by default, this is going to throw an exception, and we need to handle this exception. This is how we're going to do this. So we are going to put our line of code, which could possibly throw an exception in a try block. This is what we do. And if an exception is thrown, we are going to catch that here. Notice that we are using the exception class. This is the base class for all exceptions in C++. So here we hope to enable polymorphism because we have a base reference here. And the error we get will be the most specific we can get for the kind of exception that was thrown in our try block here. So this is going to use polymorphism. And this is all built into C++. You notice that we didn't have to set up this exception class. It is built in, and all we have to do is know how to use it and use it in our C++ program. So this is something we can do to handle a built-in exception, and this is going to throw a bad cast exception. So some of you are going to ask, how do you know which kind of exception something is going to throw so that you know how to handle that? And I am glad you asked. And the way we all know is by reading the documentation for what we are trying to use. In this case, we want to do a dynamic cast. So it makes sense to look for the dynamic cast documentation in your favorite C++ reference. I am going to use CPP reference here. And if we go down, we're going to see the syntax we can use to do a dynamic cast. We get a new type as something we get out of this transformation. Expression is going to be the input to our dynamic cast. And down here, we're going to see that if the cast is successful, dynamic cast returns a type of type new type. This is what we expect here. And if the cast fails and new type is a pointer and we are casting to a pointer right here, it returns a null pointer of that type. So if we are casting to a pointer, this becomes easy because we can check for the null pointer. But if the cast fails and new type is a reference type, this is going to throw an exception. You see that we have this information here that matches a handler of a type std bad cast. So all we really need to do is handle the exception of std bad cast. And if our cast fails, we're going to catch that and prevent our program from crashing. And this is what we are going to do in a minute when we hit Visual Studio Code and try this all out. So let's go there and actually do this. Here we are in our working folder. The current project is catching standard exceptions. We are going to grab our template files and put them in place. And let's open this up in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file. We can clean it up a little bit and remove whatever we don't need. And we are going to set up our animal class inheritance hierarchy just here in the main CPP file to make this really simple. So we have our base class, which is of type animal. We have a bunch of virtual methods. So this is going to be using polymorphism. We can really do whatever we want with this. Once we have this class inheritance hierarchy, we are going to create an animal object. Can do this and say animal and try to cast this to a feline. You notice that this is an animal object. So this is an object of the base class and it really has no feline information inside. But we are going to try and cast this to a feline reference. Let's do that. We are going to say feline and say feline ref. And we are going to do a dynamic cast. And our new type is going to be feline reference. We can do something like this and we will try to cast our animal object to a feline reference. This is what we are going to try and do. But notice if we try and run this program, we are going to get a crash because this is going to throw an exception. As we have seen in the documentation, the cast here is going to fail. We already know that because this animal object really doesn't have any feline information to give us through this cast. So this is going to fail. Let's try and build this. We're going to pass this through GCC. And we are going to bring up a PowerShell window we can try and use to run our program. And you see that our program is going to terminate immediately, and it is going to tell us that we have an STD bad cast exception here. So all we need to do is handle this exception because now we know that the exception is there. Now what we are going to do is wrap our offending line in a try and catch block. We can do something like this. Let's grab this and put that in here. And we are going to catch our exception. We can put that below. Let's do a catch. And we are going to catch an STD exception. And we are going to grab this by reference. And inside, we are going to say that something is wrong. And we are going to try and print the what message we get from our exception. And from this, you should know that standard exceptions are going to have a what method, which is going to give out what is wrong. And we can really get all this information from our documentation. So if we look at our exception class, we can crack it open. We can go down and see what we have inside. And this is what it looks like. And you notice that we have a what method, which is going to return a const char pointer. It is a virtual function because this is going to be using polymorphism, and it is no except. So from this what function, we can't let an exception propagate out because that would terminate our program, as we already know. So this is how I know these things here. Okay, now that we have this, we can really try this out. Again, the goal is to make our program not crash if something goes wrong, like we have on line 30 here. And we're going to say stdc out and say and to know when our programs runs to completion. Let's say stdendl here, and we are going to pass this through our compiler. The build is going to be good, and now we hope that if we run the program, we are not going to terminate unexpectedly because of this line here. Now that we are handling the exception properly, and we are handling a built-in standard exception, this is going to be doing polymorphism because we are going through a base reference, and this is going to dynamically resolve this exception to be an STD bad cast exception. We're going to see that when we run our program here. Let's run Rooster, and we are going to see that something is wrong. And if we print out what kind of error we have, we're going to see that we just did a bad cast. This is really how you can handle these standard exceptions. The key is to know that what you are about to do may throw an exception. And if you know that it may throw an exception, you're going to handle it and everything is going to flow in place. We are going to stop here in this lecture. And the next one, we're going to show you that you can actually throw these standard exceptions. Go ahead and finish up here and meet me there.